Hi there! In this video we're going to talk about how to graph a parabola, one that's of the form y equals ax squared. So how do we do this? We're going to use a table or a t-chart to find 5 points to graph, and then we can plot our parabola. So a couple things that you'll want to remember. I'm just going to zoom in here and draw a couple things for you. So when we're graphing a parabola, the parent function, or the most basic parabola, is a graph that looks like this: y equals x squared. It kind of looks like a U, like this. And this graph has what's called an axis of symmetry. So along this green line, I want you to imagine that you can take this graph and you can, if it was on a piece of paper smack dab in the middle and you folded it in half, it would reflect over that line. So whatever's on one side would be on the other side. We're going to use this also to our advantage when we graph this type of parabola. So when we make our t-chart, we have to actually choose our own x values. So a couple things you want to remember. You want to always choose 2 negative numbers, 0, and 2 positive numbers, because you want to see what's happening in the negative area of x's, in the positive area, and what's happening at 0. And you want to choose easy to plug in numbers. And by easy to plug in numbers, it might change depending on the equation that you're given. So we're going to start off with this one here. We're going to graph y equals 2x squared. So you kind of already have an idea. The parabola looks like this. So we're going to see what happens to the parabola when now I have a number in front, this a value. That's what this whole lesson is all about. When we have an a value in front, how does it change my parent function or my y equals x squared graph? Okay, so typically when I graph a parabola, I stick with the points -2, -1, 0, 1, and 2. Those are my easiest ones to plug in for negative numbers. 0 is obviously the one that you choose for 0, and then my 2 easiest to plug in positive numbers. Okay, so I'm going to use this equation here, y equals 2x squared, to get my y values. So I'm going to set up my skeleton. So I have y equals 2 times blank squared. I'm going to write this all the way down because I'm using my same equation to plug in all of these. 2 times blank squared and y equals 2 times blank squared. Okay, so here I have the x value of -2, means I'm plugging in -2 here. So I'm going to plug in -2 here. Now when you evaluate, remember you have to use order of operations. So I have to do my exponents first. So -2 squared is 4, and 4 times 2 is 8. This gives me the ordered pair, -2, 1, 2, 8, 1, 2, 3, 4, 5, 6, 7, 8. Whoops, sorry about that. 1, 2, 3, 4, 5, 6, 7, 8. Here. Okay, now here's my x value of -1. That's going to go here. -1 squared is 1, and 2 times 1 is 2. So I'm at the point -1, 2. When I plug in 0, my x value here is 0, so here is going to 0. 0 squared is 0, and 2 times 0 is 0. Here. This x value is 1, so here in my equation I'm going to plug in a 1. 1 squared is 1, and 1 times 2 is 2. And last but not least, this x value here is +2, so here I'm going to plug in a +2. 2 squared is 4, and 4 times 2 is 8. So 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay, now I can graph my parabola. Like that. Okay. Now, a couple things that you'll want to notice or remember that we did talk about this line of symmetry. So when we have an equation that looks like y equals some number x squared, the line of symmetry is always going to be at the origin, or at this, sorry, not at the origin, through the origin on the y-axis. So you can see that over here when I graphed the point -2, 8, see the distance between -2, 8 and my axis of symmetry is 2, And then I can reflect it over and I automatically get a bonus point over here. So technically, I didn't have to figure out this last one. I could have just reflected and say, well, here's a point. I know this is my axis of symmetry, so I get a bonus point over here. When I did the second one, this guy right here, when x is equal to -1, I plug in -1 here. It's a 1 away from my axis of symmetry, so then I can just go reflect it over the other side and I get another bonus point. So technically, I didn't have to find that one either. But if you're still feeling a little bit shaky about axis of symmetry, you can always just plot 5 points and it will work every time. Let's try one more. Okay, this time we're graphing y equals -1/2 x squared. Now, remember I told you you had to be careful about the points that you chose, that you wanted easy to plug in points. I chose different points this time. I chose -4, -2, 0, 2, and 4 because when I have to take a number and I have to divide it by 2 or multiply it by 1/2, so I didn't want to get any decimals because that's harder for me to graph. So I just made sure I picked different numbers so that I have easy to graph points. So I'm going to do my skeletons again. So I'm going to write this out. Y equals -1/2 times blank squared, 1/2 times blank squared times blank squared equals -1/2 times blank squared, and y equals -1/2 times blank squared. Okay, so here my x value is equal to -4. I plug in -4 right here. -4 squared is +16, and 16 times -1/2 is equal to -8. So I'm graphing -4, 2, 3, 4, 5, 6, 7, 8 here. Okay. Here my x is equal to -2. So in this spot in my x value, I'm going to plug in a -2. -2 squared is +4. And +4 times -1/2 is equal to -2. So I'm at -2, -2. Here my x value is 0. I'm going to plug in a 0 right here. 0 squared is 0, and anything times 0 is 0. So my point is 0, 0. And just in case you're confused, I know my point is 0, 0 because this is my x value and this is my y value. Okay, next, here my x value is 2. I'm going to plug x in here. 2. 2 squared is 4, and 4 times -1/2 is equal to -2. So I'm at the point 2, -2. Again, you'll notice here, because I'm still on my axis of symmetry as my y-axis, that if I'm plotted my bonus point over here, it's 2 away from my axis of symmetry. I can just reflect that right over the line. And let's try it this way. If I just say, oh, I'm going to use my bonus point, I'm going to say, well, here I'm 1, 2, 3, 4 away. So 1, 2, 3, 4 away would be right here. So I can do my point right here. And let's just see if I'm right. So this point right here is -4, so I would plug in a -4 here. -4 squared is +16, and +16 times -1/2 is -8. So I would go 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, and I end up where I thought I would because I reflected it over my axis of symmetry. Now we can go ahead and we can draw our parabola. Like this. Okay, so what did you notice? How does having this a value, how does my a out in front, and I'm talking about when it says y equals ax squared, change my parent function, y equals x squared? So let's just do a quick recap here. So quick recap. So here is a graph of my parent function y equals x squared. So if my a value is positive, so I'm going to turn on the one graph that we did. What do you notice? What happens to my graph? Okay, it kind of shrinks down. It gets smaller, or what I call, it turns skinny. So we can write over here, when my A is positive, it is a skinny graph. Or we say it condenses. Okay, when my A value is between 0 and 1, so let's turn on this guy, 1/2. What happens to my graph? I can see that it got fatter, or it expanded. I call that a fat graph, or an expansion. We can say that it's fat or expanded. Okay, and then what happens when your A value is negative? So I'm going to turn this off. And if we look at graph number 4 here, we'll notice that it has a 1/2, so it's going to be expanded, or a fat graph. And what happens to my graph? We notice that it flips over my x-axis. So when A is negative, what happens to it? We can say it flips over your x-axis. Okay. If you have any questions about how to graph a parabola, please let me know, or if you have any questions about how an A value changes the parent function, also let me know. Good luck.